Hello everyone, welcome back to this tutorial. In this tutorial, we are going to look at circle theorems. Our objective, we will draw a circle for a given radius, state and use circle theorems. Now let's look at a circle as a locus. A locus is a set of points that meet a given condition. Example, if you have been asked to draw the point 6 centimeters away from the point P in a plane. Now, if I have this to be my point P, I have another point. Now, the distance between these 2 points, let's call it 6 centimeters as we've been given. Now, if I have another point, set of points, which is having the same distance, 6 centimeters from point P, then when we join all these points, we are going to get our circle. We therefore define circle as a locus of a point, a given distance from a given point in that plane. Now let's look at part of a circle. We are going to consider circumference, radius, and diameter of a circle. If I have this to be my circle, I have the center of the circle O, then I have a point A. Now the distance between A and O, we call it radius. Now I have another point B. Now the distance between O and B is also a radius. Therefore, we have OA equal to the radius, then OB equal to radius. Now, the distance between AB is also called diameter. Now, OA plus OB equal to diameter. Therefore, R plus R equal to diameter. 2 of the R will give us the diameter. Now, we also have this to be the circumference of the circle. Now, let's look at chord, arc, and a sector. Now, if I have this to be my circle, the line AB is called chord. Now, this AB with the red color is what we call minor arc. Then this is what we call major arc. Then we have this area to be minor segment. Then here to be major segment. Now let's look at sector and tangent of a circle. If I have this to be my circle with the center, then I have radius and another radius, giving me these 2 radius. Now this area is what we refer as minor sector. Then we have this to be the major sector. Now if I have a line AB, which is tangential to this circle, so this is what we refer as tangent. Now let's look at rule 1 of our circle theorem. For rule 1, if I have this to be my circle and I have the center O, then I have a line from O to B, then I have another line from O to C. Let's call this angle A. Now, if I also have a point at the circumference, let's call it A, then I have a distance between the A and the B, then I have another line A and C. Let's call the angle formed at the circumference as B. Now, we are concluding that when this thing happens, our A is equal to 2 of the B, if you look at this figure 1. Now, let's look at this one. If I have another circle, A, then I have a center O, I have a chord B and C, which sustain an angle to A. Then we have this angle, let's call this angle B. Then it also sustains an angle to the center, let's call this angle A. Again, our A is equal to 2 of the B for the figure 2. Now, then we conclude that angle at the center of a circle is twice the angle at the circumference. Now, let's look at an example. In this example, we have been asked to find the value of x. Since 2x equal to 70 degrees, then we are going to get our x equal to 35 degrees if we divide both sides by 2. Now, let's look at our rule 2. If I have this to be my circle, then I have this to be the center O, then AB being the diameter. Now, if I have a distance AB, then I have a distance BC, We are saying that the angle formed is 90 degrees. Therefore, we conclude that angle ABC equal to 90 degrees, which means that angle from a diameter at a circle is 90 degrees. Now let's look at this example. We have been asked to find the value of the angle XYZ. Now the angle YZX equal to 90 degrees. Then we are going to get 90 degrees plus 30 degrees plus the angle XYZ equal to 180. Then we are going to get XYZ equal to 180 degrees minus 90 degrees minus 30 degrees. XYZ equal to 60 degrees if we subtract 90 and 30 from 180. Now let's look at rule 3. Now for this figure, we can see that the arc AP sustains an angle to the circumference at F and at E and at D and C. Let's call this angle at FA, at EB, at DC, then at CD. We then conclude that A equal to B equal to C equal to D. Therefore, angles from the same arc at a circumference are equal. Now let's look at this example. We have been asked to find the value of x. Now from this, we know that the arc AB sustains an angle to the circumference at D, and the same arc sustains an angle to the circumference at C. Therefore, x is equal to 32 degrees. Let's look at rule 4. Now, if you look at this diagram, we have a quadrilateral inside a circle that we normally refer to cyclic quadrilateral. We are saying that a cyclic quadrilateral is a four-sided polygon with vertices on the circumference of a circle. Now, if you look at the vertices, we have the x, y, z, and w. Now, in this case, opposite angles in this cyclic quadrilateral added to 180 degrees. Therefore, A plus B equal to 180 degrees. And AD plus B equal to 180 degrees. Let's look at this example. In this example, we have been asked to find the value of x and y. We know that from this diagram, 118 degrees plus y equal to 180. Therefore, y will be equal to 180 minus 118 degrees. And we are going to get our y equal to 62 degrees. Now, the second question asks us to find our x. We know that our 2 of our x will give us y. Therefore, we are going to get 2x equal to 62 degrees. If we divide both sides by 2, we are going to get x equal to 31 degrees. Now, let's look at rule 5. If I have this to be my circle, I have this to be my point C, then I have another point A, which join for us to get the line AC. Then I have another line ED, which is tangential to the point or to the circle. If we have this, then that's how we call the tangent. If I have this angle to be A, then we have another point B which joined the point C to get a line BC. Then let's call this angle B. If we also join the line BA, then we are going to say that the angle DCA is equal to the angle ABC. So we are going to get this angle to be A. Then again, angle BCE equal to angle CAP. Then we are going to get this angle to be B. Then we conclude that angle between a chord and a tangent is equal to angle in the alternate segment. Now let's look at this example. We have been asked to find the value of x and y. Now from this diagram, we can see that angle BAC equal to angle ADC. Therefore, x is equal to 86 degrees. Again, angle ADC equal to angle AEC. Therefore, we are going to get our y equal to 86 degrees. Now, let's look at rule 6. Now, if I have this to be my circle, then I have the center O. I have a point P, which join from the center for us to get the line PO. Now, our OP or PO equal to radius. Now, if I have a tangent, a line AD, which is a tangent to this circle, we conclude that a tangent AB to the circle at P, the tangent and the radius meet at 90 degrees. Therefore, we are going to get this angle to be 90 degrees. Now, let's look at our rule 7. Our rule 7, if we have this to be our circle, we have a point A and we have another point P, which join together. Then we have another point B. Then from point B to point P also join a line. We conclude that AP is equal to BP. Therefore, the line AP here is equal to the line BP. So in conclusion, we are saying that two tangents to a circle from the same point are equal in length. Now let's look at this example. In this diagram, we have been asked to find PAC with reasons. Now, if we look at the triangle APB, is an isosceles triangle, meaning that the length PA and PB are the same. Therefore, we are going to get angle PAB equal to angle PBA, which will give us 2x plus 68 degrees equal to 180. 2x equal to 180 minus 68 degrees. So we are going to get 2x equal to 112 degrees. If we divide both sides by 2, we are going to get x equal to 56 degrees. This is the end of our tutorial on circle theorem. I hope you enjoy it and you continue to watch our videos. Bye bye.